The test scores of one class on the Unit 2 Mathematics test are shown in the table below. Find the population standard deviation of these scores to the nearest tenth. So I've jotted down here the scores and frequencies as they were given in the table for this problem. So they want us to find the standard deviation. That's the goal of this problem. Well, we can't find the standard deviation until we know the average. So first we'll find the average, and then we'll find the standard deviation. So how do we find the average? Well, average is pretty easy, right? In general, you just add up all the numbers that you have and divide by how many there are. But they haven't given us a list of all of the possible grades. Instead, what they've given us is a score frequency chart. So if they've given us the frequency, that means there's one student that got a 96, there's two students that got a 92, there's 5 students that got an 84, and so on. So to really get the average, to find the sum of all of these, we have to multiply the score by the corresponding frequency and then add each of those products up to get the total score. And then we have to know how many total scores there were, so we have to add up all the frequencies. So the total number of students is 1 plus 2 plus 5 plus 3 and so on, and this works out to be 22, and you can confirm that if you want to check the math. And now let's go ahead and set up the average. So the average we represent using the variable x bar. That's our variable for the average, x with a bar over it. And so that will be 96 times 1 plus 92 times 2 plus 84 times 5 plus 80 times 3 plus 76 times 6 plus 72 times 3, and I don't think I'm going to fit this in, so I'll just throw it over here, plus 68 times 2. And all of that gives us the total score. That's our numerator. That's the sum of all of the scores of all the students. And then we have to divide that sum by the total number of students, which is 22 students. So if you do that math, if you work out that numerator, you should find that the numerator turns out to be 1,748, and you can check this on your calculator. And denominator turns out to, obviously denominator is 22. We did that over here. It's the total number of students. So the average score on the test was 79.45. So that's the average. That's x bar. Now the standard deviation is a little trickier. So to get the standard deviation, we have to find out the distance or the difference between each of the scores and the average. And then we have to square those differences, add them all together, divide by the number of students, and at the very end take the square root. So the formula for this is that, so the standard deviation, the variable we use is sigma, so that's the standard deviation, and it equals the difference between each score x and the average x bar squared for every different x. And we're going to add all those together. So that's the summation. And then divide by the number of students at the end. So we'll call this n. That's n. And if we don't take the square root, we have to take the square root at the end, so oftentimes the way this is written is that this will be sigma squared, so the standard deviation squared will equal this summation. So in order to actually solve this, we don't really have to use the summation. We can actually solve it out by plugging in the individual numbers. And I'm going to try to do this as succinctly as possible. I'll keep this as sigma squared for now, and then we'll take the square root at the very end. So sigma squared equals, and now we want to do each score x, so we'll start with 96, minus 79.45. And I don't want to write 79.45 over and over and over again, so I'm just going to write x bar here. But you know that that number is 79.45. So we're going to find that difference, the difference between that score and x bar, and square it. And then we're going to keep going. So we're going to now add 92 minus x bar, and we're going to square that. But we're going to have to do that twice because there's two people who scored 92. So as a shortcut, I'm just going to multiply that by 2, so I don't have to write it twice. I'm going to use that shortcut again. It's going to be 5 times 84 minus x bar squared plus 3 times 80 minus x bar squared. And I'm going to keep going on to another line here. 6 times 76 minus x bar squared. Now if you're worried that you can't do 76 minus x bar because x bar is 79, which is greater than 76. Well, actually, it's okay because you'll get a negative number, right? It'll be negative 3.45 or whatever, and then that'll be squared. And when you take a negative number and square it, you get a positive number. So it's taking those differences, and by squaring them, it's making them all positive, and then we're going to take the square root at the end. So we'll see that it still works out. Next we have 3 times 72 minus x bar squared plus 2 times 68 minus x bar squared, and that's it. So that is the entire numerator, and then the denominator is that we're going to put this whole thing over 22. And if you're wondering what that numerator comes out to be, you can do it in your calculator. I got 1193.455 when I did it over 22, which turns out to be 54. Well, actually, I didn't even calculate what that was. I just went directly ahead to the next step, which is that I took the square root of both sides. So you get rid of the squared and take the square root of what you have on the right. And what you'll ultimately get is 7.3653, which is approximately equal to 7.4. And that's how we're going to leave our final answer because they asked to have it to the nearest tenth. So sigma equals 7.4. And finally, just in closing, if you don't want to go through this whole process, most graphing calculators can do average, which is mean, so that's finding x bar. That's pretty easily done. And they can also do standard deviation, sigma. So you can plug in, there's a way to plug in your calculator, you give it a list of scores and frequencies, and it'll automatically crank out the mean x bar and the standard deviation sigma for you. But it is important, it's an important statistical concept that comes up. You should certainly know how to calculate the average. You won't get far in your SATs if you don't know how to do an average. And standard deviation, I know it's a little tedious, but it is useful and it is an important concept to know. So I recommend at least knowing how to do it by hand, even if you do plan to use your calculator when you take the Regents.